Hey guys, this looks like a fun one. It says find some integers a, b, c, and d that satisfy this equation. A over b plus c over d equals a plus c over b plus d. In the general case, this is not true. Here's a counterexample. 3/5 plus 4/6 does not equal 3 plus 4 over 5 plus 6. And most of the time this won't work. But the question is asking, can we find some integers that will work? Well, let's see if we can do it. So I'm thinking first, let's isolate one of these variables. Let's get the a all by itself. We can move this a over b over here by subtracting a over b from both sides. On the left-hand side, a over b minus a over b will cancel each other out. And on the right-hand side, let's move it up here. Now on the right-hand side, we have two fractions. Let's give them a common denominator. For this first fraction, let's multiply top and bottom by b. And for the second fraction, let's multiply top and bottom by b plus d. Now everything will have the same common denominator of b times b plus d. And on top we'll have b times a plus c minus a times b plus d. And this will still be equal to c over d. Next, up here we can distribute this b to both of these terms, and we can distribute the negative a to both of these terms. It'll be ba plus bc minus ab minus ad. This ba is the same thing as ab, and this positive AB and this negative AB will cancel each other out. And now we can smush everything together. We're still trying to get this A all by itself, so there's no A's in the denominator. Let's multiply both sides by the denominator. On the left-hand side, we can combine all this and we can move the C over here. So we have BC times B plus D over D. And on the right-hand side, this on top and bottom will cancel each other out. We'll end up with negative AD plus BC. Next, we can subtract BC from both sides. On the left-hand side, we can stick it in here like this. And on the right-hand side, these will cancel each other out. Before we move on, I want to clean up this left-hand side. Let's give these a common denominator. Right now, this is BC over 1. So if we multiply top and bottom by D, it'll be BCD over D. And now that these have the same denominator, it'll be a single fraction with D as the denominator. And on top, we can do BC times B to give us BCB, plus BC times D, which is BCD, and then we can subtract BCD. This positive BCD and this negative BCD will cancel each other out. And we can rearrange the BCB into BBC. And we can rewrite the BBC as B squared C. And now we've simplified all this into B squared C over D. And next, let's multiply both sides by 1 over D. On the left-hand side, the denominator will now be D squared. And on the right-hand side, these will all cancel each other out. And now I'm just realizing on the last step, we could have divided by negative d, but that's fine. We'll just multiply both sides by -1. On the left-hand side, this would be negative this fraction. And on the right-hand side, these two negatives will cancel each other out. So we have a is equal to negative b squared c over d squared. And now let's see if we can find some integers for a, b, c, and d. So c, I think, could be any integer, but the a depends on the fact that b squared and d squared have to simplify. So let's make b a 4 and d a 2. So the 4 squared is 16 and the 2 squared is 4. Those will simplify. And then let's do 3 for c. That means a would be negative 16 times 3 over 4, which is negative 12. And now we have 4 integers that should work. It'll be negative 12 over 4 plus 3 over 2. And we're going to see if that equals negative 12 plus 3 over 4 plus 2. Let's simplify both sides and see if they end up being the same number. On the left-hand side, let's give them a common denominator of 4. So it'd be negative 12 over 4 plus 6 over 4. And on the right-hand side, we can simplify these. Negative 12 plus 3 is negative 9, and 4 plus 2 is equal to 6. Negative 12 over 4 plus 6 over 4 is negative 6 over 4, and we can bring down the negative 9 over 6. Each of these will simplify into negative 3/2. So this is one case of integers that works. Let's put a box around it. How exciting. And here's a teaser for the next episode. Given the areas of the 2 circles inside of the square, can you find the area of the rectangle? That looks like a fun one. How exciting.